types of biosensors, different types of biosensors which are there, and little bit of science which will make the theoretical background for creating some new biosensor devices. I will also cover major part which I would like to uh, say cover in the total electronics part. So the electronics behind the transducer is more important from my point of view, and I hope that for the young entrepreneurs and for students, basically at say graduate or postgraduate level, they will be able to devise some biosensors. Okay. So let us start with the first slide. First slide. Yeah. So the biosensors is basically an analytical device which converts a biological response into electrical signal. In biosensor, the biological material is used to interact with the analyte. It is often used to cover sensor device in order to determine the concentration of the substances and other parameters of biological interest. They do not utilize a biological system directly. It is often considered that enzymes are the biologically responsive material, but it should be recognized that other biological system may be utilized by biosensor. For example, the whole cell metabolism and the ligand binding and the antibody antigen. Let me say ligand is basically is an ion or molecule which binds the central metal atom to form a coordination complex. It involves formal donation of one pair of electron or a sort of some electron to metal in contact. It is called as a metal ligand bonding. Ranges from covalent to ionic bond. Uh, a biosensor could be the catalyst, say biocatalyst, which converts substrate into product. Biosensors recognizes a molecule which binds to the biomarkers. So the recognition molecule could be aptamer, enzymes, or antigen, or antibodies, or maybe nucleic acid. It leads to signal, right? So with the help of transducer, we try to capture this signal. It may be optical, electronic, magnetic. We use analytical devices which measures the concentration of an analyte. The current endeavor concerns potentiometric, amperometric biosensors and calorimetric paper enzyme strips. A successful biosensor must possess at least some of the following beneficial features. Like the biocatalyst must be highly specific for the purposes of analyte, which should be stable under normal storage condition. The reactant should be as independent of each physical parameters as stirring pH and temperature as it is manageable. This would allow the analysis of samples with minimal pre-treatment if the reaction involves cataphours or the coenzymes. This should preferably also be a co-immobilized with the enzyme. And the response which we get from the biosensor should be accurate, precise, and it should be reproducible, which is a very good feature of any good kind of biosensor. And it should be linear over the useful analytical range without dilution or concentration. And also, it should be free from the electrical noise. There are many types of biosensors. Let us say briefly, the biosensors are electrochemical biosensors, thermometric biosensors, then optical biosensors, piezoelectric biosensors, immunobiosensors, whole cell biosensors. Okay. So
So when you want
okay,
to
let us
change the
see.
slide, then let me know. Okay.
No. Just a minute. Okay,
Okay.
this is the first slide. Yeah, this is the first slide, which
Yeah.
may look as a say a ready-made one, but it is nice. So in this slide, we will see that the part A, which is a which acts as a biocatalyst, and then other parameter say B is a transducer. So transducer is a major thing which converts some kind of analysis into electrical signal, and then the whole output is processed further. Means if the signal is small, it is amplified. To what extent you have to amplify, it is your decision, it is your own design. Then the display may be analog or digital. And nowadays, with the help of microcontrollers like Arduino or uh, Arduino controller, you can control and display a lot of things with this, right? Okay, next slide. Here,
This one
next slide. Yeah,
or
yes.
this one?
So, yeah, no, next one.
Okay.
Yeah. So this is more simpler diagrammatic representation of biosensor. Here we will see that there is some biological material which leads to biological response, and other physical component which gives to uh, electronic response and leads to measurement. So this is how diagrammatically the biosensor can be explained. Next. Okay, next slide. Okay, thank you.
Yeah.
Yeah, this one. So here I would like to give the example of the strip, glucose strip as a biosensor, which is the very best example of a potentiometric biosensor. We all of know that in a simple circuit, the charges contributes to the current, right? So if the circuit is there and if the charges are flowing through the circuit, to which we say that it's a current. So the when current is flowing through the circuit completes. And if we could measure this current in terms of the quantity which is proportional as an analyte, we can measure the output, right? So so the design of the strip is that it consists of substrate, right? And on the substrate there is a chemical mixture which turns glucose into electricity, and the enzyme acts as a mediator. So what happens when if there is increased blood, and in the blood if the glucose is there, which is high or low, it will knock out the electrons, and that electron will contribute to the current which is measured on the glucometer in terms of sugar content, right? So the sugar content will be gram per liter, right? But the actual unit is different. And the strip, which looks very simple, but it is not so simple. The design is very complicated. We can see that the very first layer of the strip is a substrate which attracts liquid, Then there is a adhesive strip, and there is a spacer. Again, there is a adhesive, and under that there is the electrical circuit, which we have to insert in the glucometer. Okay. So for this strip, the care has to be taken that for each lot of the test, the strip is made from the same batch of chemical mixture that is used to generate electrical signal, so that the glucometer will show the uniformity in the reading. So this is how a simple potentiometric biosensor work. Now we will go to second slide. Next slide. Yeah. Okay. Now, there is a scope of various electronic components and devices, starting from resistor, capacitor, diode, Zener diode, light emitting diode, light dependent resistor, thermistor, transistor, photodiode, phototransistor, photocoupler, piezoelectric sensor, optical fiber, and many electric integrated circuit. So we can make use of these devices as a major component, say transducer, which will give you the uh, electrical signal, right? So with this we can design our biosensor. So let us start with next slide please. Yeah, so this is a temperature adjustment thermistor, which is a ready-made also, and we can see the schematic diagram of the thermistor, how it looks. If we see the simple resistor in the block, right, then the thermistor sensor is shown in the another blocks, right? And there is a schematic of a variable resistor which looks little different than this. We can see it. And then there is another schematic diagram of LDR. So LDR is a light dependent resistor whose resistance changes with the light. So basically LDR are the NTP devices, called as a negative temperature devices. So normally what we see is a positive temperature coefficient devices all around us, whose resistance changes with the temperature, but its resistance changes, and it decreases with the increase in the temperature. But as a device, this is a ready-made form, uh, and this the thermistor is useful for measurement of the temperature. We can see on the left hand side it has a four leg. One is analog input, ground, positive, and uh, fourth point is a digital output, right? So what happens uh, in the electronic part, that this signal is processed for the output. So when suppose suppose the suppose the uh, blood is there, and if we suppose we want to measure any cholesterol level, then what happens? When the blood enters the substrate, the heat is generated, and substrate has to be there in the closed container. So if the thermistor is there, the thermistor will measure the burnt value of the cholesterol, and this will increase the temperature inside the enclosure, and this is how the cholesterol will be measured. So various material like glucose, uric acid, they can be measured with this thermistor biosensors. Uh, Different tests are there, like ELISA test. This is also the test which can be measured with the thermistor biosensors. Okay. Next. Okay. So here the diode, the very important components of the electronic devices. Say diode is a PN junction. It starts with the anode and cathode. Then there are different types of diodes, say Zener diode and all that. On the right side of this, I have given two. I have differentiated two diodes. One is a light emitting diode and other is a photodiode. So photodiode is a light sensor. It receives the light, and the incident light is converted into electrical signal. And LED is the light emitting diode. So if you uh, provide the supply, if you connect the voltage to the diode, then it will emit the light, right? So this is the diode. Next. Yes. Next to diode, it is a transistor. So transistors are often called as a small signal amplifier. Uh, See the right hand side of the diagram. It is a circuit diagram where if we consider that signal as a say V in. So V in is a small signal, and and the signal is further amplified with the help of transistor. Basically, transistors are the combination of two diodes connected in back to back. So for transistor, there are three important terminals: base, emitter, and collector. The current base current will define the amount of current which flows through the collector. So basically, the transistor amplification is known as IC is equal to IB into beta into IB. So beta is a factor, amplification factor of that particular transistor, and depending upon the beta factor, the transistor will amplify the signal. They also acts as a switch also. So actually a lot of things are there, but we can get information of transistor, how it operate and all that from this side. I have given downstairs side HTTP www address for transistor biasing and studying transistor in details. So I will not go into detail right now here. Next. Yeah. Okay. Another important aspect of this phototransistor, it is a transistor, but it has only got two terminals, and they are called as a collector and emitter. So here there is no base, since base is hanging, and it is made effective for the incident light. So in the miniaturized size, it comes the field effect transistor, which are very small in size, and they also works like a transistor. And this phototransistor, if the surface area is dark, the device is off, and when the surface area is illuminated, it gives you a reading, and this will create the electrical signal, and which further analyze, and then the quantity, the whatever you want to measure can be measured at the output of the biosensors. Practically, if the no current is there, then the collector to emitter region will remain open. Right? Just like a regular transistor, it works. So there are a special kind of uh, transistor. It is called as a field effect. So they are of a very small size. Again, one has to go to this site and learn more about the field effect transistor, which normally the, the this sensors are used in the optical biosensors. So optical biosensor nowadays they are very large in use, since in the material science the optical sensors are developed by the community in electronics, and it has got a lot of advantages. One of the major advantage of this biosensor is that they do not require any comparative signal, because the comparative signal is the same source of light in the form of reflection, because we make use of light for say refraction, dispersion or interference in the biosensor design. Okay, next. Right, optocoupler. Optocoupler is again a special kind of design. It is a complete circuit. See here, in this circuit, there is the output of any timer. If it is a timer, the timer input is given to this device. The optocoupler directly connected to the output, and we can use this same thing to the Arduino board. Arduino boards are the microcontroller where you can analyze the signal. So the optical couplers are ready-made thing where you don't have to use light source and detector as a photodiode. This is again a very versatile device and used majorly for the opto biosensors. Next, yeah, okay. Operational amplifier. Operational amplifier is again uh, used in large scale. This has got advantage over the transistor. They are miniaturized in the size, and what we get is a V output. The V output is nothing but the V reference voltage, and uh, uh, the input resistors decides the signal. Means if you connect resistor, there are various voltage which gets divided, and this input of the voltage is first referred with the non-inverting input of the amplifier, which is shown as with a plus sign, and negative as a non-inverting input, and at the output you will get the signal, right? So operational amplifier has a two input, inverting input and non-inverting input. There is a important terms in terms of operational amplifier. It is called as a virtual input. So when you give input, say to say non-inverting input, you have to first nullify the effect of any other input by making voltage zero, right? So this is called as a virtual input, and virtual output has to be zero prior to measuring any input signal which goes to the amplifier. So 7 IC741 is a very widely used in the electronic devices. There are many operational amplifiers, and a lot of things can be learned again from the site electronics tutorials, and we can learn about the operational amplifier, right? So um, operational amplifier has a voltage gain, which will be dependent upon the V reference. So V reference is the resistor applied between output and input of the operational amplifier. Okay, next. Yeah, okay. This is again the basic amplifier as a transistor 5 BC4 5541 or BC547 as a device where we can send input signal between capacitor C1 and ground, and amplified signal will be at the output. This is very basic circuit. but instead of single transistor, we can use multiple transistor to get a noise free amplified signal. That is why I have shown this. Okay, next. Yes. Okay. There are various sensors available in the market and on the Amazon also. So this is a temperature sensor. This is a say electronic device which senses the temperature. We know that our body skin act as a temperature sensor to the human. So we can feel the heat outside or in the atmosphere or surrounding us. But if you want to capture this heat, we can make use of electronic devices. In this diagram, the heat sensor is shown, and to the right there is a sensor. It is a humidity sensor. All these things are available on the prototypesupplies.com. There are many sensors similar to this also, and we can make very effective use of these sensors in devising the biosensor or say any concrete design. Next. Yeah. Okay. While explaining transistor as a switch in a biosensor, uh, I am showing this circuit. So in this circuit, actually, it is very complicated circuit at a first glance. But let me say that suppose in the transistor, if you give any input to the base, say B1, right, to say my left, then you will get IC at the collector side, and to the collector you can connect any relay or any switch, and you can connect that relay to further devices like a motor or any centrifuge water pump, and which can be controlled with the transistor. So the transistor acts as a controller to the pump, and you can give signal, and depending upon your choice, and you can control the switching of the motor, external motor, and you can pump water in or out. Right. So a lot of things are again given on the that site, which is again given at the bottom of this slide. So you can go there and access the material. Next. Yeah. Okay. So this is the universal voltage and current device. This is basically a voltage regulator. So we may call this as a eliminator or the power supply. So what are the major component of this power supply? There is a transformer. There are some diode called as a rectifier diode. There are some big value capacitor like 1000 microfarad and 25 volt, which acts as a filter for AC. And there are some component like IC7812, which is a voltage regulator. It's an integrated circuit. If you give input any unregulated power supply to pin number 1, at the base value, say IC, when it is at the ground, it will give output which will be a constant voltage, right? And the voltage will be constant, and this is the main need of any biosensor or any electronic device. That is why I have shown this. And if you want to make any mini voltage regulator, we can build that voltage regulator using single transistor. But for that, you need to have a Zener diode. As I have described various types of diode, so the Zener diode are also acts as a voltage regulator, and we can simply put one decoupling capacitor in parallel with the Zener diode and appropriate load resistor, and you can connect this circuit, and you can get output at the emitter. So this is also a small voltage regulator, which is very simple to build and make in the house also or in the laboratory. Okay, next. Okay, so the this diagram little bit shows that how the operational amplifier works. So in this operational amplifier, I have shown with the pins, right? So the pin 1, pin number 2, and pin number 3. So here I have tried to explain little bit of the functionary, how the photo transistor works and how the input goes to it, and then how the output is obtained as an output signal at the pin number 1, right? So here we could see that there is a photo transistor at pin number 3, and this is the whole circuit. It's a ready-made circuit, I can say. And if you connect the devices according to this, then you will be able to get the signal at pin number 3, and this signal will be compared with the signal or the voltage at pin number 2, and this compared signal is will be fed to the operational amplifier, and you will get output, right? So the output will be stable depending upon the uh, time period of the capacitor which you have used as a timer. So in this picture, you could see that 100 nanopicofarad capacitor is a timer, right? Which will decide the output signal, right? Okay, next. Okay, here again some transducers are there, like say digital thermometer, sensors, and some piezoelectric sensor. So here you see that one more in addition to this, the piezo sensor is there. So what is a piezo sensor? Actually, basically we know that piezoelectric effect. When if you take any crystal of say piezoelectric, for example, barium titanate, like that, where if you apply any pressure to any two faces of the crystal, the opposite faces there will be a voltage generation, right? So in piezoelectric effect, we make use of many input. Means input could be say stress or strain, or any acceleration, or any mass, right?
Next. Should I
Just
move
a
to the
minute.
next? Okay.
So we know that in our house also we use lighter in the kitchen, for lighting the gas. So that lighter also works on the same principle of piezoelectric effects. So it basically creates electrical signal. So when the input is given, the output is in the electrical form, which can be processed further with your amplifier or your microcontroller or something like that. Okay, next. Yeah. Okay, here it is a infrared sensor. Infrared sensor is again a very small miniaturized device, where there are two components. Basically, one will be infrared light emitting diode, and other will be receiver, like say photodiode. So in this case, it is basically used in the optical bio sensors. The light, when the light is there, it is the light is made incident on say any substrate or any substance. Then the reflected light is received again on the photodiode, and it is sensed, and it is again sent to further processing. We know that nowadays the uh, infrared thermal scanners and temperature sensors are coming. Here we can make use of this sensor, infrared sensor. Downside, the block diagram is given, like how the photo sensor is shown in the picture. This is the typical diagram. Okay, next. Yeah. Okay, this is again a ready-made sensor known as a heartbeat sensor. As the new technologies are emerging, uh, we are getting ready-made sensors. We don't need to design any sensor, but we need to use these sensors for any further processing, and we we can put this directly as an input to the microcontroller and get the output. Okay, next. Okay, this is the prototype and a picture of the microcontroller, say Arduino board. This is called as a Arduino Uno. Many versions of this Arduino Uno are coming in the market. They work on 12 volt, and very small current requires for that. They even work on the battery also. We can see the slot is there. Two slots are there. One is the digital probe also, and other is analog voltage, which we can give with the eliminator, battery eliminator. And Arduino boards are basically very small thing, comes with a limited pins, and very easy to understand. There are tutorials available on the internet, and on the Arduino tutorial we can learn many things. Many things can be learned. Many tutorials are there. Uh, so these tutorials are easy to understand even for the students of say school children. They can play with the Arduino board, they can design the program, and the very important thing of this Arduino board is that they can program it, right? So the programming is done with a very simple language, and it can be we can learn programming at any stage. Even a school children can learn the programming. So the basic programming is very handy. It is the device is also very friendly. We can connect any pins to any slot and play with it, and get the signal and get the output, and design our own circuit. The mini Arduino boards are also there. I have shown it on the right hand side. So these are the mini Arduino board, which are small in size, and they can be work like the same what is the bigger Arduino board. Because uh, if the use is limited, we can shrink that size of the Arduino board to the mini, right? So restricting our use, we can use that. Okay. Next. Yeah. Okay, here I wanted to explain the energy diagram. So in the energy diagram, it is basically the electromagnetic radiation. So we can see here visible light. which ranges from 400 nanometer to 700 nanometer. And infrared devices, they they works to little higher side, which is 700 nanometer to 1 millimeter, so which is the higher side. And the advantage of this IR light is that it is invisible, so we can make use of infrared diode for sensors, right, in many devices, or for designing our own biosensors, and make use of the device, right. So I have tried to show how the light is split into different colors. Uh, we can we can have a simple DVD, and the light can be entered from one side face of the slide, and we can literally see how the light splits into 7 colors. It is just an experiment, we can do that. Okay, now okay okay now I will go to applications of the biosensor. uh, Biosensors, they are popularly used, and they must be very small and sensitive, and should be successfully used for monitoring the human body fluids, right? Because we know that we always with the bio sensor, we deal with the blood, cholesterol, urea measurement, sugar measurement, right? And as the glucose is the thing where the regular monitoring is needed, right? uh, the application of the biosensors is there in the fermentation process also. In the wine industries, the biosensors are used. We know that ATP is a factor which decides the freshness of the food material, and the ATP is also measured in the measuring the freshness of the fish, right? So the biosensors are used in the uh, factories where we used to preserve the foods. Some of the biosensors are also used in the military, like uh, then biosensors are also used in the environmental institutions for measuring, say, uh, content of oxygen, or content of any pollutant, right? BOD and all that. Okay. So next to that is properties of the biosensors. Properties of the biosensor is that the biosensor must be highly specific for the analyte. The response should be linear over a broad substrate range. The device should be small and biocompatible. It should be low cost and small and easy to carry. Low cost than the conventional one and the conventional tests. The assay should be fast and reliable and repeatable, because repetitiveness is the major task while using the biosensors.
Should I go to next slide?
Yeah, you can go to next slide.
Okay.
Okay, here I have shown the gun thermometer. So basically, this is the ready-made gun thermometer, but we can build our own gun thermometer using various electronic devices, which I have described, and simple electronic circuit like transistor, photodiode, or uh, different power supply, battery, and all that. So this is the best example of a ready-made gadget, say gun thermometer, uh, where they make use of thermopile as a sensor which receives the reflected light from the forehead of say any human being, and the temperature will be displayed on the display screen as a temperature. We know that the normal human being temperature is 35 or 36 degree. It is basically 35.7, right? So if the higher temperature is there, it immediately get identified on the screen. And now in the COVID pandemic period, very instantly we can verify whether the person is infected or not, or whether the person is ill or not. Basically we get the sense of temperature within a fraction of second from this device. Next. Yes. So this is again a thermal scanner. The thermal scanner devices are looks similar to what I have shown with the gun thermometer. But here, in the thermometer, what happens? It is basically a screen, wide screen, which which gives the thermal chart, the thermal graph of the human being, of whom you identify the temperature. So it gives you the uh, portion of the nostrils pipe, right? So with the sense of temperature without any digital sense, it gives you the color sense. Means like the blue shows you less warm, and the red color shows you the more warm body temperature, and green shows you less warm, right? So blue is the coolest one, and red is the hottest one. So basically, it is again the temperature graph, and it is used widely in many airports and many hospitals for recognizing the patient or any normal human being and its temperature graph. Okay. Okay. Next.
Thank you.
Okay. Oh, okay. This is
That's the last
last one,
slide.
right? Yeah.
Okay.
Okay. This is thanks to all the viewers also, and to basically all viewers who will become next generation learner. And thanks goes to Dr. Ranu Datta just for encouraging me, and whatever I have learned from the uh, internet site and from the science of biosensor, I have tried to deliver it. This is basically to encourage the young and enthusiastic learner, just by learning from whatever the theoretical background is there, whatever the theoretical things are available with us from say internet or Google and all that. And there is a lot of scope for the young learner and BSc and MSc graduate to go through the internet material, go through the electronic sites, starting from say Amazon.com, or any sellers, or any marketplaces, or any wiki pages which gives lots of information. Now the time is that we don't have to learn many things from our normal lecture mode of things, or we don't have to rely on our teachers many times it happens that we rely on our teacher or any mentor, and then we start. But the time is that we have to start our learning from scratch. Anybody can start from the scratch. They can take help of the internet. They can take help from the tutors, right? Lot of sites are available. You just Google it and go to the site and learn, and uh, get some electronic devices as say components, uh, play with that, start with a simple circuit, make use of a breadboard, then make use of smaller component and try some circuit, make some small circuit, and then little bit go to higher state like a Arduino board or Uno board. And to my think, it is not very difficult to anyone. Even if they start at this stage, later on they will become master, and maybe they will be an entrepreneur, and they will contribute to bioengineering. So the main thing is that the engineering part which they have to do is, of course, it depends on them, their own interest and their own creativity, which they contribute and make. Okay, so thank you, Ranu, for
Before,
all
yeah.
your
So
yes,
before you
yeah,
leave, I have a couple of questions because
yes,
your talk was very explanatory, and it had a
okay,
mixture of the biological components and both the engineering
yes,
components. So now
yeah,
my simple question would be, like, if suppose a bio student wants to design a biosensor, because he might
mm,
not be very good in physics or electronics, so where to
mm,
start with? So I want you to guide them so that, like, now they are at home and they can easily take such projects and create some biosensors. So
mm.
you are a science educator, so I would like want you to show the way how these students can actually start doing the work, from where.
Okay. So suppose okay, for this I will say, suppose if they want to make any uh, small biosensor, right? So we know that if you take a simple example of a closed circuit, right? Take a say salt solution and put some electrode into salt solution, right? So basically, if the electrodes are there, say two dissimilar metal plate, put it in the salt solution and connect any analog meter, say galvanometer, right? So by with the concentration of the solute in the solution, they will get a reading, right? So the current will be measured in terms of some milliampere or microampere, and this will indicate, and this will change with the concentration of the solute in the solution. So if the salt is more, the current is more, right? So this is how we can sense the sodium chloride in the water, right? So if you take a distilled water, we should not get any current in the meter, right? So
Okay.
if you take, or if you add some little bit of salt in the solution, the potential difference, because of the change in the charge and because of the change in the ion mobility, the current will flow in the within the electrode, and the ion electricity will be produced, and this ion electricity will contribute to the current in the meter, right?
Okay.
So this is how they have to do.
So, are there any very cheap equipments that are available, accessories, so that they can sit at home and design some? Can you give a list of some, or some references where they can get all these components of the biosensor? So,
Yeah, I have given the Amazon.com, right? On the
yeah.
Amazon, lot of biosensors are available.
Hmm.
You, I have shown you that temperature sensor over there,
Hmm.
temperature sensor.
No, I mean to design a sensor, they need accessories. So I wanted to know that where can they get these accessories so that they can get them online at home and they can start making their biosensors.
The accessories they can get in any electronic shop. Yeah,
Okay.
electronic shop or any shop where they sell loose parts of in any instruments.
So are they available online?
Yeah, they are available on the say RS components.
Okay.
RS component is a thing. Then uh, uh, red silicon. Some sites are there. Right
Okay.
now, I don't have, but
Okay.
many sites are there, which
Okay.
are there in the our slides also actually. In
Okay.
some of the slide, I have given the addresses.
Okay.
Let me see here.
So I would just request you to have a short session on components of a biosensor and how they can get
Okay.
those and start working from home. How they can design a biosensor.
Okay. See, suppose this site is there that Proto Supply, slide number 13.
Should I move the slide?
Yeah, slide number 13. You can see the address is there directly.
Okay, this one.
Yeah.
Okay, okay, okay,
So many things were there, like say enzymes and all that. Because say student, the biology student know what is enzymes and all that, right? Because
yeah, yeah,
basically enzymes are the catalyst, in the living organism.
yeah.
Uh, with in the living organism with a very mild temperature and very normal at very normal pressure. Uh,
Mm.
they carry out some chemical reaction, and enzyme is basically a simple protein which undergoes any chemical changes, right? So in a cell also, in the cell metabolism, reaction takes place, and there in the enzyme, it it doesn't go, it's in its molecular change, right? Molecular change is not there, but some chemical change takes place. So basically, the substrate on which the en, enzyme works is called as a substrate, right? And from the substrate, you get some different molecular product, and this substrate you have to use uh, in the biosensor to carry out further processing, right? So
Okay,
substrate is the main thing. One of the substrate that I have explained in the glucometer, right? How sugar is measured in the glucometer. So substrate is a important part. So the children can invent, or they can design their own substrate.
okay.
Uh, slide number 3.
Three. Yeah, this one.
Yeah, slide number 3. Yeah,
Yeah.
biological component which acts as a transducer, right? So
Okay.
transducer basically physical change or any chemical change. It takes
Mhm.
place right there, and further it is processed.
Okay. And how can the sensitivity of a sensor be increased?
Sensitivity.
Yeah.
Okay, sensitivity. Sensitivity of a sensor. Suppose it is say thermistor, right?
Yeah.
Suppose it's a thermistor. We know that normally when at a normal temperature, thermistor has a fixed resistance. But if there is any change in the temperature, then what happens? The resistivity of the material inside the thermistor it reduces, and there is a more current which flows in the resistor. And now it depends upon you to how to capture that resistance, how to capture that current, right? And this current, if you amplify with a transistor or any other device, you can increase the sensitivity of the thermistor or the sensor.
Okay.
Yeah.
Okay.
So the amplifiers and pre-amplifiers you have to use, so you can increase the sensitivity.
Okay. Okay. And about this gun thermometers that are
Hmm.
being used for COVID screening. So how
Yes.
accurate are they uh, uh, as far as the sensitivity is concerned?
Yeah. Okay. For the ready-made things, since it is a ready-made, they are pre-calibrated, right?
Hmm.
So calibration part is our own part. I told you that means if you go to slide number, yeah, slide number 16. Yeah, slide number 16, where operational amplifiers are there. Yes, yes. Here.
Hmm.
So here, this is a operational amplifier where we have to compare our input and reference voltage and get the output, right? So
Yes.
here, sorry, what is your question?
I said that in case of COVID, like you see, the gun thermometers are used for screening of high temperatures these days. So what is the accuracy of that?
Okay, accuracy is that
That is
it is
basically
accurate up
thermo.
to second digit. Yeah, it is accurate up to second digit,
Okay.
because display itself, the ready-made, they use a ready-made display, and it is a 7 segment display. Total 4 displays are there, so it is
Mhm.
accurate up to second digit. Means say normal human being temperature is 37 point not 7 degrees, something like that.
Okay. So let me ask, like, what is the degree of error that is possible with the thermosensor?
Yeah, thermosensor used in the gun
Yeah, like
thermometer.
yeah.
Yeah, it is very small, say 0.01,
Okay.
0.01,
Okay. So it is
as
quite
little.
reliable. I mean,
Yeah, yeah, 0.01. Yeah, it is
okay.
viable. Yes, it is viable.
Okay. So we are also actually working in interdisciplinary areas, and we encourage students to participate in such projects where they can work with, interdisciplinary streams. And
Hmm.
like here, the biology students are there, the physics students are there, the computer science students are there. So, can we have a group who can design some good biosensor where AI is, I mean, applied, and which can be
Hmm.
used for some biomedical application?
Yes, yes, why not?
Okay, so I would request you to guide our students in your next talk as how we can compile all these three components and where these students should start so that they can be able to develop biosensors for some biological applications.
Yeah. In
Okay.
biosensor, right, means see, suppose if you use any piezo electric buzzer, we know that the sniffer dogs, they are used as a animal biosensor, right? But if you want to design any artificial biosensor, uh, we can make use of piezoelectric crystals. In piezoelectric crystal, what happens? when there are some specific molecules, and that piezoelectric crystal will resonate with the specific frequency, right? And if we bring this frequency near to any other material, like say cocaine or something like that, so what happens? There will be a maximum displacement of the frequency, means the resonance will occur. Means if the cocaine is hiding somewhere, your pre-calibrated frequency will match with the frequency of that cocaine molecule, and the resonance will occur, and you will get some sound peak, right? And that is how you can make use of piezoelectric buzzer in obtaining the resonance and identifying the cocaine, which is hidden part. So this is the part of biosensors also. It comes under organophosphorus uh, substrate, right?
Okay. Okay. So, is there any other questions by the students? Then I will let you know.
Sure, sure.
So,
Yeah.
uh, yeah, thank you so much for your elaborative talk.
Once again, thank you
And
for
yeah, so I request you and to guide our students in designing biosensors, provide them some online internships for now, and help them design some biosensors. So
sure.
yeah, so
I will
thank you very much. I thank
definitely.
all the viewers for seeing this program with a lot of enthusiasm. Okay, thank you all. Have a good day. Bye
Thank
bye.
you, all of you. Thank you.